Alright, I got question 53 from section 8.3. Alright, it said let m and n be distinct non-negative integers, which is the same thing as positive, they just want to be fancy. They say non-negative, but it's really just means positive. Alright, so m and n are positive integers, and they want us to use these formulas, which are found in the book, and we got to prove that a couple integrals equal 0. So the first integral that we have to prove to equal 0 is this one right here. Now, as you can see, this part, the sine mx cosine nx, looks a lot like this first formula. So I just apply this formula to the integral that they gave us. I got this. I put mx as the alpha and the nx as the beta. Yeah, so it's pretty straightforward there. Now I just took the integral, distributed the 1/2. The integral of sine is negative cosine, so that's where the negative 1/2s come from. And the x and the n, since they're positive, they just kind of went away. So yeah, so now I have to plug in 2 pi and 0, so I plug in 2 pi right here. And negative 1/2 times the cosine of 0 for the first part, that equals negative 1/2. Negative 1/2 of cosine of 4 pi, which is the same thing as 2 pi, which is the same thing as 0. So that's also negative 1/2. So negative 1/2 minus negative 1/2 equals negative 1, which is nice. So now I do the same thing for 0, plug it in for x, and well, I mean, it's the same deal here. Negative 1/2 times 1 is negative 1/2, and 1/2 times 1 is 1/2, so negative 1/2 minus 1/2 is negative 1. So now negative 1 from this part minus negative 1 from this part, that gives me negative 1 plus 1, that's 0. So I proved that that equals 0. Now part B, I have to prove that cosine mx, cosine nx dx, and the integral from 0 to 2 pi equals 0. Well, as you can see, this part looks a lot like this formula. So I applied this formula to that integral. And that's where I got this from. And so now I took the integral, I took the integral, 1/2 distribute, integral of cosine is sine, x, alright, and then m and n's go away since they're positive, and that could just be represented by this x. And I got 2x here because it's x plus x. Simple algebra. It's from the interval 0 to 2 pi. So 1/2 sine 0 plus alright, yeah, so 1/2 sine 0, that's 0, plus 1/2 sine of 4 times 0, which is 0. Alright, so that's this 0. Yeah, we'll just forget about this actually. And then 1/2 sine 0 plus 1/2 sine 4 pi, the 4 pi. Sine of 4 pi is also 0. So it's just a bunch of zeros, and 0 is minus 0 plus 0, whatever, they all equal 0. So I prove that this integral equals 0. So now finally, part C, prove that this guy equals 0. Well, as you can see, this looks a lot like that equation. So I apply that equation to my integral, and so I got this, then I then I integrated, and I distributed the 1/2 out. So m and x go away, m and n go away because they're positive, so just x, positive x minus x, yeah, on the integral of 2 pi and 0. So I plugged in 2 pi first, and these all equal 0. all of them. And now I plugged in 0, and these all equal 0 as well. So 0 minus 0 equals 0. So I prove that this integral equals 0. And I'm done.